Alright, so in this problem, I have 27 to the power of x plus 27 to the power of x plus 27 to the power of x is equal to 27. So to solve this, I'm going to first start by factoring out 27 to the power of x. So now I have 27 to the power of x times 1 plus 1 plus 1 is equal to 27. Now 1 plus 1 plus 1, that's going to equal 3. So I have 27 to the power of x times 3 is equal to 27. And now I'm going to divide both sides by 3. So I get 27 to the power of x is equal to 9. Now 27, this is the same thing as 3 to the power of 3. And 9 is the same thing as 3 squared. So if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of x, that's going to equal 3 to the power of 3 times x, which is equal to 3 to the power of 2. And 3 times x is equal to 3x. So I have 3 to the power of 3x is equal to 3 to the power of 2. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, this means that 3x is equal to 2. And now if I divide both sides by 3, I get x is equal to 2 over 3. So now to check, my equation was 27 to the power of x plus 27 to the power of x plus 27 to the power of x is equal to 27. So now if I'm going to take the power of 2 over 3, so I have 27 to the power of 2 over 3 plus 27 to the power of 2 over 3 plus 27 to the power of 2 over 3 is equal to 27. Now, 27 to the power of 2 over 3 is the same thing as 9, so I have 9 plus 9 plus 9 is equal to 27, and this means that 27 is equal to 27. Alright, so in this problem, I have x to the power of 3 minus x squared is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So now I get x to the power of 3 minus x squared minus 4 is equal to 0. Now to actually find all of the solutions for this equation, we need to first start by finding one and use that one solution to find the rest. So to do that, to find the first solution, we need to just start by plugging in numbers. So if I plug in x equals 1, I get 1 minus 1 minus 4, and this does not equal 0, so this is wrong. Now if I plug in x equals 2, I get 8 minus 4 minus 4, and this does equal 0. So x equals 2 is a solution. Now using x equals 2, I'm going to divide x to the power of 3 minus x squared minus 4 with x minus 2. So now if you divide these two, you get x minus 2 times x squared plus x plus 2. And you can either divide them with long division or synthetic division. So now this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus x plus 2 is equal to 0. So for x minus 2 equals 0, this is simple. This obviously means x equals 2. And for x squared plus x plus 2 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, or sorry, b is 1, and then c is 2. So I get x is equal to -1 plus or minus the square root of 1 squared, which is simply 1 minus 4 times a, which is 1 times c, which is 2, all over 2a. And this is equal to -1 plus or minus the square root of 1 minus 8, which is -7, all over 2. And this is actually equal to -1 plus or minus the square root of 7 times the square root of -1 over 2. And if you guys already didn't know, the square root of -1, this is actually equal to the imaginary number I. So I can actually go ahead and replace the square root of -1 with I. So now I get x is equal to -1 plus or minus the square root of 7i over 2. So my solutions are x equals 2, x equals -1 plus the square root of 7i over 2, and x is equal to -1 minus the square root of 7i over 2. All right, so in this problem, I have 3 to the power of x plus 4 is equal to 4 to the power of x plus 3. So now to solve this, I'm going to first start by using the property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 3 to the power of x plus 4, that's going to equal 3 to the power of x times 3 to the power of 4. And 4 to the power of x plus 3, that's going to equal 4 to the power of x times 4 to the power of 3. Now I'm going to divide both sides by 4 to the power of x times 3 to the power of 4. So then these two cancel out and these two cancel out. So now I'm left with 3 to the power of x over 4 to the power of x is equal to 4 to the power of 3 over 3 to the power of 4. Now 3 to the power of x over 4 to the power of x, that's the same thing as 3 over 4 to the power of x. So I have this is equal to 4 to the power of 3 over 3 to the power of 4. And now I'm going to take the log on both sides. So I have log 3 over 4 to the power of x is equal to log 4 to the power of 3 over 3 to the power of 4. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 3 over 4 to the power of x. And I can move x to the front. So I get x times log 3 over 4 is equal to log 4 to the power of 3 over 3 to the power of 4. Now I'm going to divide both sides by log 3 over 4. So these two cancel out, and I get x is equal to log 4 to the power of 3 over 3 to the power of 4 over log 3 over 4. Now this is the same thing as log 4 to the power of 3 minus log 3 to the power of 4 over log 3 minus log 4. And this is equal to 3 times 0.6021 minus 4 times 0.4771 all over 0.4771 minus 0.6021. And this is equal to 0.8168.